muscle again right here?
Well, this is iris.
Iris. Okay. Yeah, I can't remember.
So that's lens, ciliary body muscle, and then ciliary processes, which we really can't see, but it's the processes that attach the muscle to the lens.
Okay.
Now let's see if we can get this guy out of the way. And aqueous humor between here and here.
Aqueous humor between.
Yeah, it's like that watery.
It's all pressure, and the aqueous humor keeps the cornea at a certain curvature for refraction.
Keeps the outside?
Keeps this cornea,
oh,
right.
Okay.
And of course, it's all flabby and flaccid now, but
yeah.
under pressure, and we pump plasma in there and we can filter it out. And we hold aqueous humor and vitreous humor to keep the pressure in the eye, interocular pressure.
How do you say the outside whiteness? Sclera?
Sclera.
Sclera.
Sclera. Cornea.
So if I can get this guy out of the way without destroying everything. Yep. So this gel is vitreous humor, and we have a detached retina. So we're trying to reattach it. Yeah, that's not bad.
Oh, that's good.
So
What's the
it's
colors?
really fragile.
What's the colors in there?
Well, we'll get to that. So vitreous humor here keeps the shape of the eye pocket, keeps the lens in place, keeps everything organized, keeps the retina buried onto the back, stuck on the back to keep the focal length the same. So we have retina here composed of, a couple of dozen different nerve types, rods and cones probably being the most well-known or obvious, that synapse on bipolar cells and synapse on Amercan cells and synapse on horizontal cells, ultimately synapsing on ganglion cells, whose axons form, now watch this one, don't rip, whose axons form, oh, it's falling apart, but the optic nerve. And we can see all of them going to the same region right here. Right. Maybe I can kind of wiggle this guy around so you can see what I'm talking about without breaking anything.
Your blind spot.
You see, everything is going right there,
Yeah.
right? And if you replant this thing, this retina didn't get fixed too well. But you can see right there in the middle, right there, everything comes together. And that would be optic disc. That's where the optic nerve is going to exit. And if you drew a line, if you stuck a pin right through what you thought was the center there, it would come right out the back end of the optic nerve, wherever it is. I can't even see it anymore.
Yeah, that's right.
I can't even see it anymore.
There.
Yeah. So that's our film for the camera. Now, what about all this junk in the back? We have
optic
two
disc
more
is the
things.
film?
Huh?
The optic disc is the film?
No, the film is the retina.
Oh yeah, the film is the retina.
Optic disc, I guess we would say, where all the afferent axons from the ganglion cells bundle up together. Now we got this behind there. We have this really pretty blue-green mother of pearl.
Yeah, that's nice.
Very pretty.
And we have black there. And we have black there. So how do you think we would orient this eye? Top, bottom, or is that top and that bottom? This is a goat, right?
Yeah, sheep.
A sheep. This is a sheep. Great. I got it all figured out now. So here, this is a sheep. You guys know what a sheep eye looks like? A living sheep eye? Who's got a... Right there. Just
Sheep eye.
Google image sheep eye. I think I got it straight, and I got to make sure. I don't work on sheep eyes. Blow one up. And turn it this way.
Oh.
Got it. Great.
Weird.
So, let's do it this way. Who's top and who's bottom
They're
here?
like rectangles.
We have black there, and we have black there, and we have a stripe of reflective material.
That's this way.
I would agree. I'm not sure which is top and which is bottom. My guess is, here's our optic nerve down here. My guess is this is top.
Yeah.
this is bottom,
Yeah.
and then depending on which eye it is, this is going to be moving horizontally.
Oh, that's for seeing. So what is that called?
So what is it? Well, what are the things called? The black area here is pigment epithelium.
Black.
It's
black,
pigmented.
pigmented.
It's important pigments too. Associated with this comes the regeneration abilities of the rods and cones with their chromophore. Then the other is the tapetum lucidum. Lucid, right? Bright.
Like carpet.
Oh, that's the bluish green in there?
Blue-green.
Okay.
And the tapetum lucidum lays, you can follow this one, the tapetum lucidum lays superficial to the pigment epithelium.
Okay.
Did you follow what I just said? So it's going to be here, and pigment epithelium is going to be here. But here we have an absence of pigment epithelium. We have tapetum lucidum. Tapetum lucidum is blue-green.
Oh,
Pigment epithelium
is black.
is
Okay.
black. So what do you think? And now we've associated this to be vertical. I'm sorry, horizontal. And we see the iris here also horizontal. What is the purpose of the tapetum lucidum?
Purpose.
To see in the dark, to assist in scotopic vision, nighttime vision. So a photon of light comes in through the cornea, through the lens, gets bent, and is focused on cones and rods of the retina and goes right through them, activates them and goes through the rods and cones, and reaches the layer superficial to the retina, behind the retina, which is the tapetum lucidum. Reflective material, pigments that are reflective in their nature, hits them and scatter back, not could go that way or that way or that way. That. So, but what are we doing? We're bringing photons back through the retina a second time to be hit with a photon of light and be activated again. So, in pitch black darkness, first of all, we don't have a tapetum lucidum. We only have pigment epithelium. We have no reflective ability at all, humans. When a photon of light hits our retina and goes through it, it gets buried and killed in the pigment epithelium.
So that's why they can run away from like wolves. Not
Well,
very
they
successfully.
have enhanced ability where we
have
cannot
night
see a
vision?
photon, they can, because the photon numbers have doubled.
You know
Because
when
they're
you
reflecting
shine
back
a light on animals at night, like their eye reflects? Like
They're-
ours don't. So that is that.
Ours do.
Ours do.
Let's
why when
see.
you take
Yours
a-
don't,
When you take a
and yours don't. Yours may.
Oh, you get
Yours
red.
do, and
Oh, yeah,
mine
he
do.
does get red eye
You
in
get the
pictures.
pink
I
eye.
get such a red eye in pictures.
So what is the
when
pink
flashes
eye?
go off.
What is it? There's
The
no.
reflection of
The iris.
Yeah,
No?
no, the iris.
No, wait. It's not iris. It's
What do? We have an anti-red eye feature on our cameras that goes
Oh, yeah.
with light, and then it takes the picture.
Flash.
so it floods the light.
It floods the eye with light, which does what?
The retina.
Nope.
Pupil?
Pupil constricts the pupil. It's still red eye, but it's unnoticeable on your camera.
That's weird.
So what is the red eye?
Red eyes.
It's not the eye. No, we just said it's not the iris because we flash to constrict the pupil, and the red eye goes away. The iris
Cornea.
actually gets bigger,
Iris. is
so
the-
it has to be deep to the pupil. It's not the lens.
The vitreous humor.
It's not the vitreous humor. That's nice and clear. What's left?
Aqueous.
Beyond that.
The
Beyond that.
The
The retina. And what's associated with the retina?
The
Did you
pigmented
say?
epithelium.
You said it like 5 times, so that's why I didn't say
You
it.
said everything though. What's associated with the retina? Neurons, of course.
Rods
Blood
and
vessels.
cones.
Blood vessels.
Oh, blood vessels.
We're bringing in a lot of blood. So that pink eye is hemoglobin. But why don't we see red with these guys? We do. These guys have pink eye as well. But it's masked by the incredible spotlight of a sun reflecting on the tapetum lucidum. There's still pink associated with it, but we got this huge.
So the cornea on us is the
blue-green light.
white that you see. Is that our cornea? The white part of our eyeball?
No.
No. I thought.
Sclera.
Oh, sclera is the white part. So where is the cornea on the blue?
It's that. It's,
Oh.
it's this
The covering.
covering, yeah. The covering over your iris.
Okay. So the iris is in ours, the blue in our eyes is the iris. Okay.
In sclera, yeah.
Me.
Mammals are nocturnal by nature. Even a cow. We evolved from a nocturnal mammal. So I can't think of any other animals that, and depending on how their iris is set up, they'll have different shapes of the tapetum lucidum. Mice
Where's the extrinsic
split in
muscles?
two, black on one half and blue-green on
The
the other half.
extrinsic
Because they're
muscles,
interested in
is that
things flying
from these?
around up in the sky.
Oh yeah, maybe that.
Dolphins, the entire back
Or
of
is
the
it the ones
eye
in the
is
back right
all
here?
tapetum lucidum
So-
because they're in three-dimensional
Are
shape.
their vision better than ours?
Who's?
All these mammals. Where are we on the scale?
That's a loaded question.
Yeah.
Is it which
In
animals
terms
are
of
you-
night vision, we have terrible night vision.
Right.
We have no night vision. We do, of course, but nothing like compared to the other animals. In terms of color vision,
We're better.
humans rule the earth. For the mammals, humans rule the earth, along with the New World monkeys, because we have trichromatic color vision, blue, green, red. Everybody else has
Um,
Black and
by